Welcome. In this lesson, we're actually going to learn how to find the multiplicative inverse, or the inverse of a matrix. Again, we're only going to be doing a 2 by 2 matrix. By the way, if they give a label to the matrix, let's say this -4001 is matrix A, the inverse is designated with an A with a little -1 next to it. It's not an exponent, it's just A to the -1 is the inverse of A. But let's talk about how we find the inverse. The first thing we're going to do is we're going to calculate the determinant to determine if it has an inverse. So the determinant is going to be equal to, now remember how we calculate the determinant is I multiply down this diagonal. So I'm going to multiply -4 times 1, and I'm going to minus off the other diagonal multiplied together, 0 times 0. So the determinant for this matrix is -4, because it's -4 minus 0, or -4. If that had turned out to be 0, I would click undefined. Since it's not 0, the inverse does exist. And this is how we find the inverse. I take the determinant and I put it in a fraction, so it's in the denominator. And by the way, this is why we can't do a inverse if the determinant 0, because you can't divide by 0. So I take the determinant, put it in a fraction under 1, and I'm going to multiply it into another matrix where I'm going to use the elements of my original matrix, but I'm going to alter them just a little bit. What I'm going to do is I'm going to swap the place of A and D. That diagonal, these two diagonal ones, I'm going to swap. I'm going to take the 1, put it where the -4 was, take the -4, and put it where the 1 was. So I swap the places. You'll notice, maybe I should even do that these two swap places to here. And then the B and the C, this diagonal, they don't swap places, they change sign. So these two change sign. So you don't need to put a negative in front of 0. I'm just going to do that to make sure you realize that you do change the sign of whatever it is. But a -0 is still 0. And then the last thing you do is you're multiplying by a scalar, distribute in the -1/4 to each of these 4 elements to write your final matrix. So I would have 1 times a -1/4. That first element in my inverse would be a -1/4. The second element, luckily, 0 times anything is 0, would be 0. The third element, again, 0 times any number would be 0. And then the last element, wow, what happened to my thing? That really was weird. That's supposed to be a -4. -4. Something really went weird because that negative even went down. But what's -1/4 times -4? That's going to be a +1. So that last element is 1. Okay, so I'm going to jump ahead because I noticed that they do a lot of these diagonal zeros. That's just a guarantee that it has an inverse, because you might get one that looks like this. Okay, so now let's first calculate the determinant to see if it even has an inverse. So I'm going to do that diagonal, -8 times 2 will be -16, minus 8 times -2 is another -16. And what's -16 plus 16? Well, that's 0. Since the determinant is 0, this matrix is undefined. So I click undefined. All right, looks like this one will also be undefined, so I'm going to jump ahead. -6 minus a -6, another one that's undefined. Maybe you'll get a lot of undefined ones. Wow, they're throwing in a lot of undefined ones. Undefined. That one has the zeros. I don't want zeros. I want to do one that's a little more. There we go. Here we go. Let's do this one. So the first thing I'm going to do, again, is find the determinant. The determinant is always the diagonal row. -1 times 3 will be -3 minus this diagonal. 3 times -2 will be a -6. So -3 minus a minus or plus 6, the determinant is 3. Since the determinant exists, the inverse exists. The inverse will be, remember, 1 over the determinant times, wow, this got messed up over here. I don't like how this got messed up. Since I think I'm sliding things around like this, it's messing it up. Remember, these two swap positions. So what I'm going to do is in my original matrix up here, the -1 and the 3 swap places. So the 3 will go here. The -1 will come down here. And the other diagonal, this diagonal, they don't swap places. They change sign. So the -2 will become +2. Then +3 will become -3. Now the last thing is distribute in that 1/3. So what's 3 times 1/3? That's 1. What's 2 times 1/3? 2/3. That's what's happening. When I start doing this, it messes it up. What's -3 times 1/3? Excuse me, -1. And what's -1 times 1/3? -1/3. If you have any questions, please do bring them to class, and I will help you then.